Okay, let's graph this function. We have f of x equal a minus 1 over b minus x, where x belongs to R, not only to R, because we have condition on x that it does not equal to b. This means x belongs to R without b. This is the domain. Domain of our function is x belongs to R without point b, which is a positive value, right? Because it's given b is positive value, b belong to R plus, and a belong to R plus as well, as and a times b, both a times b, the product of a times b is greater than 1. A times b is positive for sure because both positive, but he wants me to put a times b greater than 1. We will see why. He wants me to sketch this graph showing clearly the asymptotes on the graph, and write the equation of these asymptotes, and write the coordinates of the points of intersection of that the curve crosses this the coordinates axis. That's great. Let's start. First, first f. First, this is the domain, right? Without b, this means x not equal to b. What's the meaning of x not equal to b? This means directly that x equal b is a vertical asymptote. What else? As x approaches positive or negative infinity, this means that f of x approaches what? A minus 1 over b minus of plus or minus infinity. So this is infinity, plus or minus infinity. 1 over infinity is 0, so the answer will be a, and then y equal a is a horizontal asymptote. Those are the equations of the asymptotes. X equal b, y equal a. That's great. What else we can have? What else we can have? Let's find the first derivative, f prime of x or y prime. What is f prime of x or y prime equal to? What is the derivative of a? Constant, it's 0. Minus, what is the derivative of minus 1 over b minus x? It's u over v. If y prime, it will be equal u prime v minus v prime u over v square, right? So derivative of minus 1 is 0 times b minus x is 0, minus the derivative of b minus x is minus 1 times minus 1, it's plus 1, so minus 1 times minus 1, it's plus 1 times minus, it's minus 1 over b minus x all square. That's nice. B minus x all square, we know that it does not equal to 0, and it is positive value, so this is strictly positive value, so the derivative, the first derivative, will be strictly negative value. That means that f is strictly increasing function over our domain, which is R without point B. Let's do also the second derivative, because to be more accurate when we draw. Okay, this second derivative will be u prime v minus v prime u over v squared. This means over b minus x to the power 4. A derivative of minus 1 is 0 times b minus x squared is 0. Then minus 1 times derivative of b minus x squared, which is 2 into b minus x, into derivative of minus x, which is minus 1. The final answer is going to be minus times minus 1 times minus 1. Again, it's minus, it's minus 2 into b minus x over b minus x to the power 4. We cancel b minus x. What left is minus 2 over b minus x cubed. This is good. This is good. Can we say that this is negative or positive? No, it depends on the value of b minus x cubed. B minus x squared, we know that it's strictly positive value because x not equal to b, and it's squaring, but b minus x we don't know. So if b minus x is positive, what does that mean? This means minus x is greater than minus b. This means x is less than b. If x is less than b, that makes b minus x positive. This value is positive. Cube it, it will remains positive. Minus 2 over positive value. This means the derivative, the second derivative, is negative value, and we have concavity upwards. Concavity, sorry, downwards, because it's negative, downwards, right? If b minus x is negative value, this means minus x is less than minus b. This implies that x is greater than b. When x is greater than b, this means that the second derivative is positive. The second derivative is positive value and concavity upwards. That's nice. Concavity upwards. Okay, let's find the points of intersection and draw. Points of intersection. If x equals 0 means what? Let's go again to the function a minus 1 over b minus x. So y will be equal a minus 1 over b minus x is 0. So that's it. we can take common denominator b, so it will be ab of minus 1 over b. So let's take point A, 0 abscissa AB minus 1 over B to be point of intersection with the y-axis. And this value simply is positive value because AB is greater than 1. That's what he said. So it's this value minus 1 is positive over positive, so it's positive value. If x is, if y in this case now, if y is less than 0, less than 0. If y equal to 0, this implies that 0 equal a minus 1 over b minus x, then a equal 1 over b minus x, cross product ab minus ax equal to 1. So ax equal to ab minus 1, this implies that x equal ab minus 1 over a. And also this value is positive value, ab greater than 1 minus 1 is greater than 0 over a, which is positive. So positive value over positive value. Let's be ab minus 1 over a, and ordinate 0, also a positive point. That's great. Let's draw the asymptotes. Let's draw the horizontal asymptote, which was y equal a, and the vertical asymptote was y equal x equal b. X does not equal b in the denominator, so it's a vertical asymptote, right? It's vertical asymptote. So those are the asymptotes in red. What else? Let's do the table of variation. We forgot the table of variation, which is the most important thing here, right? The table of variation. Okay, let's do that as fast as we can because the time is almost over. Okay, what is this? The vertical asymptote, right? B not in the domain. That's great. The derivative, if you remember, the first derivative was strictly negative, and the second derivative was I guess it's negative below b and positive above b. Negative x below b, it's negative, right? When x less than b, the function is negative. The function is negative. When x greater than b, the function is positive. And this is the function here, f of x. It's strictly increasing function. No stationary points over here. As x tends to minus infinity, it's a. As x tends to plus infinity, it's a, the horizontal asymptote. And here, minus infinity plus infinity at b minus b plus, where we have vertical asymptote. So we are almost done. The points, okay, this part here is easy, goes from positive infinity of the asymptote b plus to the right of b down to the asymptote a with no points of intersection. So it comes something like that, down to this asymptote, right? And this part over here goes from this asymptote, this is totally wrong, this asymptote as much as I can to this point, do not cross. This asymptote goes down. This point here, I think so, I name it A, right? Because it's 0 abscissa and ordinate whatever. This is A, and this point we named it B, and this one is Y equal A, and this one here is X equal B, and it's done. So, and we still have time. Let me talk about that. As you can see, this is second derivative. The second derivative is negative below b. So this is point b, right? This is point b. Below b, it's negative, so concavity downwards. And above b is positive. Look at that. Concavity upwards. Let me continue this asymptote, right? And let's continue this a little bit, right? This is an asymptote. Okay, and this number here is simply, it's a. And that's everything.